Hello, May class, and welcome to your next maths lesson. So we're moving on a little bit from division, but we will be using the skills that you've just learned during multiplication and division to look at something we call correspondence. Now, correspondence is the way that something is connected to something, or a connection between something. So bearing that in mind, let's have a go at the work today. So your arithmetic, I'm going to read it to you. Please make sure to have your pen and your paper with you, and we will give this a go. So I will read them to you, talking through anything that you may misunderstand. The first question is 9 times 8. The second question might be a little bit difficult, and don't panic about it when you read it, but it says, what integer represents the 10th? So an integer is a whole number. So what number represents the 10th? So I want you to think about a whole number can be a negative number or a positive number, but what integer, what number is representing the 10th column? So if we have a look, I'm going to give you an example with the positive ones. So 4 represents the 400, 5 represents 50, 6 represents 6 in the ones column. Then our 2 represents what column? Our 3 represents something. And that little dot there means that those are fractions or numbers below 0. So it is a number. I will give you a clue on the right-hand side of the little dot or the full stop, whatever you want to call it, the decimal point, and then it is one of the numbers on the right-hand side of that. Okay, that's my clue. So what is 248 as a Roman numeral? What number is next in this sequence? 125, 100, 75, and 50. We've got 7 times by 6, 54 times 9. Sorry, I'm just going to read some over again. I got a bit lost there for a second. 10% of 860, 4,353 minus 2,110. Put these numbers in descending order. So descending, 3, 9, 1, 5, and 6. And 44 divided by 4. Right, so we are saying, can we solve correspondence questions or problems? So these are problems that'll have possibly more than one step that we need to do. They will be connected together. So again, we're going to have a 2-minute challenge. So set yourself a 2-minute timer and see if you can complete this question. Using only these digit cards and a maximum of 2 multiplication symbols, how many different totals can you make? I'm going to give you an example. Let me get my pen. So if we said, for example, I could have, you can only use, it says, a maximum of 2 multiplication symbols. So I could do 5 times 3 times by 2. I could do 53 times by 2. I could do 35 times 2. How many different totals can you make? So how many questions can you create using these symbols, and how many different totals can you make? Remembering what we've learned previously about 5 times 3 times 2, and 2 times 3 times 5, and 3 times 5 times 2 being all the same because we've just mixed your numbers around. So have a thought of that. So set your timer, 2 minutes. How many different totals can you make using these number cards and multiplication symbols, but only no more than 2? Right, off you go. Right, so correspondence problems are problems where a certain amount of objects are connected to another amount. So the object number is connected to another amount. In this problem, we have 2 types of bread connected to 3 types of fillings. The goal is to find out all the possible fillings that we could have. So a canteen has 2 types of bread and a choice of 3 sandwiches. So you have white bread and brown bread. We also have cheese, tuna, and chicken. List the different sandwiches that can be made, okay? And one has already been done for you. So we could have cheese on white. We could have cheese on bread, on brown. We could have cheese, or we could have tuna on white, tuna on brown, chicken on white, chicken on brown. So how many more, or how many different sandwiches can we make with a filling? So one filling, one choice of the bread. How many different sandwiches can we make? So write them down there. Then it says complete the multiplication to represent the number of different combinations you can make. So you would need to complete the following sentence. If we have 2 choices of bread and we times it by 3 choices of fillings, our answers would be 2 times 3, which gives me 6. There are 6 combinations that we could make. Let's have a check if I am correct. So we have got white bread. I'm going to put brown bread over here. So you could have white bread with cheese, white bread with tuna, white bread with chicken. Could I do anything else? No. Next one. I could have brown bread with cheese, could have brown bread with tuna, and I could have brown bread with chicken. And if I add all of these together, I see that I can have a total of 6 different combinations for my sandwiches. How would this change if there were 4 choices of sandwich filling? So imagine we had cheese, tuna, chicken, and a 4th choice of jam. So now we have 4 filling choices, but we still have 2 choices of bread. If you can imagine that you would say white bread to 1, 2, 3, 4. We'll use a different color for brown bread. Brown bread would be 1, 2, 3, 4. So each type of bread can go to 4 different fillings, which means you can get 4 different sandwiches with the white bread, 4 different sandwiches with the brown bread, which means that our combination would be 2 times by 4 because of the 2 breads and the 4 fillings, which equals 8 different choices for our sandwiches. Okay, so a pizzeria, that's a place that makes pizza, offers a choice of bases and toppings. So deep pan and thin base. Then we have mushrooms, chicken, onion, peppers, and sweet corn. Complete the multiplication to work out how many different combinations of pizza there are. So if we only have 1 topping and 1 pizza base, that's what we're working out. So our question would have 2 different pizza bases times by 1, 2, 3, 4, 5 different toppings would give me 10. There are 10 combinations of pizza. So I could have deep pan and mushroom, deep pan and chicken, deep pan and onion, deep pan and peppers, deep pan and sweet corn. Okay, and then you could do the same with the thin base as well. Right, let's move on to the next page. Right, so now it's going to be your turn. You're going to pause the video at each slide and complete the questions. after you've gone through them, I will go through how to work it out with you. But I don't want you to just wait until I give you the answer. So pause the video. I'll read through the question. Then you can pause it, work it out, and then you can carry on, and then I will give you the answer to that question. Okay, so the first question says, Mo visits the fun fair. He buys a ticket that allows him to choose one ride and one game at the fair. Mo says that there are 8 different possible choices of ride and game. Is he correct? I want you to then explain your answer and list all the different choices Mo can make. And then you give me a total at the end of how many different choices Mo can make. So pause the video now and work this one out for yourself. Right. So as before, if we look at this, we've got 1, 2, 3 different rides. And he says he thinks that there are 8 possible choices of rides and games. You're allowed to do one ride and one game. So is he correct? 1, 2, 3, 4, 5. There's 5 games and 3 rides, which together would make 8, but that's not what the question is asking us. The question is asking how many different possibilities does he have if he were to do a ride and a game? How many different choices would he make? So he is not correct. So my question would then be 3 times by 1, 2, 3, 4, 5. 3 times by 5, because if I'm going to do them in different colors. So if he went on the Big Dipper, he could get the Big Dipper and Hook a Duck, Big Dipper and Basketball, Big Dipper and Coconut Shy, Big Dipper and Lucky Dip, and Big Dipper and Test Your Strength. So already with one ride and one game per the choice, I've already got 5 different possibilities. I'm going to use my red to show you the dodgems. The dodgems would be the same. You could do dodgems and Hook a Duck, dodgems and Basketball, dodgems and Coconut Shy, dodgems and Lucky Dip, dodgems and Test Your Strength. And that's another 5 possibilities. The last one we'll do in that color, the carousel and Hook a Duck, carousel and Basketball, carousel and Coconut Shy, carousel and Lucky Dip, and carousel and Test Your Strength is another 5 games and ride choices that he could make. Explain your answer. So I could explain it in a full sentence by saying there are 3 rides, 3 rides and 5 games. Each ride and game mixture has 5 options. So my question would then be 3 times by 5, which gives me 15. So underneath you would list what they were. So you could say it's the Big Dipper and the Hook a Duck, the Big Dipper and the Basketball, and you could carry on and you could list those just like I've linked them here, which means that the answer is he has got 15 different choices if he chooses one ride and one game. Our next question says, Aisha has 3 headbands and 5 hair slides. Kim has 2 headbands and 6 hair slides. Who has more choices? And I'm going to underline that because that's the important bit that we need to remember. More choices of combinations. So more choices of combinations for wearing 1 headband and 1 slide. So They're not going to put all of them in, so you can only choose a headband and a hair slide to wear. How would we work these out? So pause the video now, thinking about Aisha would have a total and Kim would have a total. So pause the video now and work out this question. Well done. So I know that Aisha has 3 headbands and 5 hair slides. So much like the question before, I would take 3 times by 5, and that will equal 15. So she will have 15 choices of combinations. Okay. Kim has got 2 headbands and 6 hair slides, which means it's 2 times by 6, and she's going to have 12 choices of combinations. Right. So who has got more choices? Aisha's got 15. Kim has got 12, which means that Aisha has more combinations. So give yourself a tick if you manage to work that one out. So next one. Here are the activity choices available at summer camp. So you've got sports, arts and craft, and outward bound. Each child is allowed to choose 3 activities a day. So they can choose a sport, arts and craft, or outward bound. 1 sport, 1 art and craft, 1 outward bound. How many activities are there? So I want you to think how we've worked out the other ones with 2 choices and think about working it out with 3. So pause the video now and complete this one. Once you've completed that, it says, due to a flooded pitch, football is cancelled. How many combinations are there now? And then you would tell me a total for that. So there's 2 totals. So pause the video now and work out your answers for me, please. Well done. So your question would have been the following. You would have counted each one. So there's 3 sports. There are 4 arts and crafts, and there are 3 outward bound activities. So your question would have been 3 times by 4 times by 3. And 3 times 4 would have given me 12 times by 3 would have given me 36. So at the beginning, there were 36 combinations of 1 sport, 1 art and craft, 1 outward bound. Due to the football pitch being flooded, the football is cancelled. So if we took away the football, so we take it away, now the sport only has 2. I'll do it in a different color so you can see. So we've cancelled football and we've only got 2 sports, 4 arts and crafts, and 3 outward bound. So our question is now 2 times by 4 times by 3. And I know if with my associative law that 3 times by 4 is equal to 12 times by 2 gives me 24. Could have also gone 2 times 4 is 8 times by 3 is 24. So due to a flooded pitch, football is cancelled. There are 24 combinations. So give yourself a tick if you managed to do that. If you didn't, try and correct your work and see where you have gone wrong. Right, next question. Tom and Esther are building a snowman. They have a choice of 5 hats, 4 scarves, and 2 pairs of gloves to dress their snowman. How many different combinations are possible? So it's a very simple one where you need to use the numbers that are given to you to work out the possible combinations that are given. So pause the video now and work out these combinations. Well done. Right, our combinations are as follows. We would say 5 hats times by 4 scarves times by 2 pairs of gloves. So it would be 5 times 4 times by 2, and I can do 5 times 4 is equal to 20 times by 2 gives me 40. So there are 40 different combinations possible when building a snowman. If you are feeling unsure about working these ones out, remember your associative law. 5 times by 4 times by 2 is the same as 4 times by 2 times by 5, and 2 times by 5 times by 4. We just are moving the numbers around, and they all give you an answer of 40. So that is your maths for today. We don't have any independent task because you have been working through these with me. Perhaps if you would like to challenge yourself, you can create your own correspondence word problem. So you could give me a word problem. So use some of the names, maybe some sports, create your own one and show you're working with that. But yes, well done today. Please remember to share your work on Tapestry. Make sure that we are able to see your work, and please try and get it up before 4 o'clock today.